Stressed element in a machine component is subjected to 150 megapascal tensile stress in x direction, 50 megapascal compressive stress in y direction, and 100 megapascal shear stress clockwise on x phase. Compute the values and orientation of the principal stresses and maximum shear stress using graphical method proposed by Moore. Moore circle must be drawn on graph paper using appropriate scale. Note: analytical solution and solution without graph paper will not be evaluated, right? So they are very particular that you have to solve this graphically and on uh, graph paper only, right? Without that, it will not be evaluated. That is what they are very clearly stating in this particular question. Okay, now let us start solving. Solution. Let me just copy this from here. So given data, 150 megapascal tensile in x direction. So sigma x is 150 megapascal positive because it is tensile. 50 megapascal compressive stress in y direction. So sigma y is minus 50 because it is compressive, and 100 megapascal shear stress clockwise on x phase. So that will be positive 100 megapascal. Then theta is not given here. Just remove this. Compute the values and orientation of principal stresses and maximum shear stress using graphical method, right? So you have to find the maximum principal stress, minimum principal stress, and angle, right? So now if you are having a large graph sheet, you can use scale 1:1. If it is small, you can take 1:2. So I am using 1:1 here. Scale 1 mm is equal to 1 megapascal, right? So let me go to the graph sheet now. So first I have to draw OJ, which will represent sigma x, which is 150 megapascal, and from O I have to draw minus 50. So the total length, that is this length from here to here, this will be more than 20 centimeters, right? So I'll start from here at this point, right? So I will take this as O. Now OJ is sigma x, which is 150 megapascal. This is, so that will be 150 millimeter, 50, 50, 50. So this is point J now. Let this be J. Then sigma y is minus 50. So OK will be in this direction. So this point will be K now. This is K. Alright. So this is 150, this is minus 50. Now tau xy, that is shear stress, is 100 megapascal. So from here I have to draw 100. So okay, it is going to be very big. I'll not be able to accommodate in this. So I will reduce the scale. Right? I'll take this again, 0.5 2 megapascal. 1 mm is equal to 2 megapascal. 1 is to 2 scale. So I'm just decreasing the size because it will become very big and I'll not be able to fit in this sheet. So this is 150. 150 by 2 is 75. Right? So this is 50, 60, 70, 75 is here. I will just draw a small line like this. Right? So this is my point J. And then
Sir, it is 65.
why 65? It is 150. It's not 130. 150 by
आपने
2.
65 पे मार्क किया हुआ है.
Oh, okay. Sorry. Yeah. So 60, 70, 75. I thought you were telling the value is wrong. This is 75, correct? Yes. Thank you. So this is J. Okay. Now sigma y is 50. So 50 by 2 is 25. So this is 20, 25 here. So 25. So this point is K. Okay. Now at J and K, I have to draw the shear stress. Shear stress is positive. So at J, I will draw a line equal to 100 megapascal. So 100 by 2 is 50 mm. Just from here, draw a line till here. And at K also, you have to draw a line in opposite direction. Shear stresses are always opposite to each other and they are in a pair, right? So what do you call this as? D, and this will be E. Now what to do? Just join D and E. Right? From here to here. Just join this. Now this point is C. Now with C as center, CD as radius, draw a circle. So I will use red color now. Draw a large circle like this. So from there, yeah. So I have drawn the circle. Now let me just name the points. So this point will be G, this is G and this is H, right? I'm using, if you're seeing, same notations so that it is easy for me to remember. Now what is asked in the question, see he has not given any inclination uh, in this numerical. Compute the values and orientation of the principal stresses and maximum shear stress, right? So I'll just copy it from here. Major principal stress. This is all I need, right? So major principal stress is OG. So from O to G, this length you have to measure and convert that to scale. Minor principal stress is OH, you have to measure this length, right? Then angle JCD, this will be 2 theta P, 2 theta P1. So theta P1 will be half of this. Measure this angle, divide by 2, that will be theta P1. Then maximum shear stress is CY. So from C, draw a line like this. So that is actually the radius of the circle, more circle. So this is Y. So measure this length, you will get tau max. That is all he has asked. Now let me just move it onto the side here, and then I will draw it here. 150 and 50, right? So I'll have to draw a line like this. So this is 50, 150. This dimension. This is 50, 150, 10 tau, no problem. 10 tau xy is 100. It is positive, so from here it will be like this. Please mute. This is 100 and this is also 100. Right? Now this point is bisecting this. So with this as center, you have to draw a circle. So from here, this is my circle. Now I extend this line till here. Right? And I will also draw a vertical line here for radius. Okay, now let us measure the values. Ta-da. Okay, this is O from here to here. This length is 191.42. OG is 191.42 MPa. This is actually troubling me. Right. So 191.42, 95.71. This will be 95.71 mm. Similarly, this is interesting. Let me take you to graph sheet here. See, OH, that is the minor principal stress, is on the negative side. O is your origin. On the right side, you have positive normal stress. On the left side, you have negative normal stress. So the maximum principal stress is equal to OH, and that is compressive. It is negative, right? So you have to be careful with this. Now from here to here, this is my minor principal stress 91.4. 91.42, that is 45.7 mm. Okay, uh, angle from here to here. So this angle is 45 degree. This is 45 degree. So theta P1 will be 45 by 2, which is 22.5 degrees, and theta P2 is theta P1 plus 90 degree. So this will be 22.5 plus 90, 112.5 degree. Okay, and maximum shear stress is this 141.42 megapascal. So by measurement you should get 70.7 mm, right? So that's the solution to this.